Hello and good morning, everyone. So, in the last class, we did some definitions and terms, and the last topic which we were doing was enthalpy. Now, let us revise this again. What is enthalpy? Enthalpy means the total heat content of the system, and it is denoted by H, and it is equal to the sum of internal energy U and the product of pressure and volume PV. So the formula becomes H is equal to U plus PV. Now just remember, this is very different from entropy. Entropy is denoted by S, and it means the degree of randomness or disorder in a system. If there is a disorder in a system, that is called entropy, and the maximum disorder is seen in gases. So the entropy is maximum in gases, and the least entropy is in solids because there is minimum disorderness in solids. This is enthalpy, which means total heat content, how much heat is present in the system. Now, this is a derivation which we were doing in the last class, change in enthalpy. Now, change in enthalpy means the heat absorbed or evolved by the system at constant pressure, and your delta H, change in enthalpy, is equal to QP. Now, QP is the heat evolved at constant pressure. If I write QC, it will be heat evolved at constant concentration. If I write QV, it will be heat evolved at constant volume. So now for exothermic reactions means the energy is being released after the product formation. That means system is losing its energy. And in the last class only I told you, if system loses its energy, it means system is doing the work. So delta H will become negative and QP will also become negative. बट फॉर एंडोथर्मिक रिएक्शंस में क्या होगा, सिस्टम विल एब्जॉर्ब एनर्जी फ्रॉम द सराउंडिंग, meaning surrounding is doing some work on the system, and when surrounding works on the system, then delta H and QP, they are both taken as positive and work is also positive. We have already done this in the last class. You can see the video again if you have a problem. Now this is a very important derivation, and this formula which we will get from this derivation, there are a lot of numericals which may come in exams and are very important, so you should know how this formula is derived. Let's start with this reaction. I have taken a reaction A to B. Let HA be the enthalpy of reactant A and HB be the enthalpy of the product. Now, if I know the formula of H, I just read it. H is equal to U plus PV. So, if I write enthalpy for both reactant and product, so it will be HA is equal to UA plus PVA, and for product B it will be HB is equal to UB plus PVB. Now how much enthalpy change has come? It will be calculated with this formula, delta H is equal to HB minus HA. Just remember, in the last class only I told you that this delta means change, and this change can be shown by subtracting the final value from the initial value. Now this is the final value which is the product, and this is the initial value which is the reactant. So delta H is HB minus HA. Now putting the value of HB and HA in the formula. Now if I solve it, there is minus outside. If I open the bracket, it will be minus UA and minus plus minus PVA. So I take UB and UA together. UB minus UA becomes delta U, and I am taking common from PVB and PVA. I am taking common P. So in the bracket I'll get VB minus VA, which becomes delta V. So your formula becomes delta H is equal to delta U plus P delta V. This is the first formula that we have got. This is also used in your numericals. Now you have read that chapter called States of Matter. In that you read about ideal gas equation. So this is the ideal gas equation. PV is equal to nRT. Now for reactant A, the formula will be PVA is equal to NART. Pressure, rate, this is the gas constant R, and temperature, these are constant. Now for the product B, PVB is equal to NBRT. Since the reaction is the same, so pressure तो change नहीं होगा इसमें, pressure will be same and gas constant will also be same, temperature is also same, we have kept the temperature constant, only the volume is changing and number of moles, this is the number of moles. Now if I have to calculate how much change has come, so I'll subtract the PVB with PVA. It will become PVB minus PVA is equal to NBRT minus NART. Now if I take common P, it will become VB minus VA, which becomes your P delta V. And on this side, taking common the RT, so in bracket you will get NB minus NA, and this is number of moles of product minus number of moles of reactants. So this becomes delta N or delta NG. So I've got this value of P delta V. Now putting this value of P delta V in this equation which we got here. So in this we put the value of P delta V, it becomes delta H is equal to delta U plus delta NGRT. So this is an important formula that you will be using in your numericals. Let's see how the numericals come in the exam. So you will be given a reaction and the question is the enthalpy change delta H is given for this reaction, and it is with minus sign, it is negative. That means the reaction is exothermic. Temperature is given 298 Kelvin. If the temperature is in degrees Celsius, you will change it into Kelvin by adding 273 to it. Now you have to calculate delta U, meaning you have to calculate the energy, internal energy. So I know the formula delta H is equal to delta U plus delta NGRT. I have this delta H is given and temperature is given, but I have been given the reaction. So if the reaction is not balanced, so you have to balance it first. So I have to calculate delta Ng first. It is number of moles of product minus number of moles of reactant. Number of moles of product are 2 and number of moles of reactant. There are 2 reactants, so you will add the reactant ka moles first, 1 plus 3, and then you will subtract it from 2. So it becomes 2 minus bracket 1 plus 3. It will be minus 2 moles. Now the value of gas constant is always same. You have to remember if the units are in joule, Kelvin and mole. So this is the value that you have to use of gas constant, 8.314. Now putting all these values that are given in the numerical, in the formula that we have, you will calculate delta U. And since the value is, you can calculate in joule or in kilojoule, it doesn't matter. But you have to remember if there is a negative sign, that means the reaction is exothermic. And in some questions they will ask, is the reaction exothermic or is the reaction endothermic? So by this sign you can calculate it. Now this is another numerical. This you will do in your notebook as your homework. Try to do this question. It is the question from NCERT, so it's quite important. Now let's go on to enthalpy. There are different types of enthalpy. Enthalpy means basically energy only. So enthalpy of neutralization. Now what is neutralization reaction? You have done it in your 10th class when acid reacts with a base to form salt and water. It is called neutralization reaction. So this is the same only when a solution of hydrochloric acid is added to a solution of sodium hydroxide, which is a base also called alkali. Alkali are water soluble bases, and when they are dissolved in water, heat is released. This is an exothermic reaction, and the energy which is released in the form of heat is your enthalpy of neutralization. This is your enthalpy of neutralization. Now in case of strong acids and bases, the net reaction in the neutralization You can calculate that by adding hydrogen ion which comes from acid and OH negative ions which comes from base, and they add together to form H2O. So this is the definition of enthalpy of neutralization. The enthalpy change when 1 mole of H positive hydrogen ion from an acid, they are completely neutralized by a base, or 1 mole of OH negative from a base. So, and when they both react, they are completely neutralized. Now this is an important law, the Hess law. What is Hess law of constant heat summation? It states that the enthalpy change or the heat evolved or absorbed in a particular reaction is same whether the reaction takes place in one step or the number of steps. Meaning, if there is a reaction, if it is taking in one step or if it is taking in 2 3 steps, so the enthalpy change will be same of a particular reaction. Now there are some reactions which can take place in one step, and the same reaction you can carry out in a number of steps also. So enthalpy change will be same if you are carrying out a reaction in one step or if you are carrying the same reaction in different steps. So when the reaction takes place in different steps, you will add the total enthalpy of all the steps. So it will be same only, which is coming in the single step. Now what is bond enthalpy? Bond enthalpy means when a chemical bond is formed, so some energy is released, and it is the same energy which you will require to break the bond. मतलब जितनी एनर्जी बॉन्ड बनने पर रिलीज हो रही है उतनी ही एनर्जी लगानी पड़ेगी उसी बॉन्ड को तोड़ने के लिए. तो दैट इज़ योर BDE, bond dissociation enthalpy, the amount of energy required to break 1 mole of bond. This is important, 1 mole of bond between atoms in the gaseous state. That is your BDE, bond dissociation enthalpy. Example is given of hydrogen molecule. If I have to break the bond between two hydrogen atoms, so the bond energy released is this. Now what is enthalpy of atomization? It is the same only. The enthalpy change in breaking 1 mole of a substance completely into its respective atoms. So this is the important definition. You can also learn this definition. The enthalpy change involved in breaking bonds between atoms is called BDE, bond dissociation enthalpy. Now, what is your first law of thermodynamics? The first law of thermodynamics was very simple. It states that energy can neither be created nor destroyed. It can only change from one form to another. You studied it in ninth class also. And the formula that we got from first law of thermodynamics was delta U is equal to Q plus W. We did it in the first class. That was your first law of thermodynamics. Now there is a limitation also, demerit of first law of thermodynamics, which is called spontaneity. Now, first law of thermodynamics only tells you that energy can change from one form to another form, meaning energy can transform. But there, all the physical and chemical properties which takes place, it says that total energy will remain constant. Now, it doesn't specify the direction in which the change will take place, meaning it does not explain in which direction does the transformation takes place. It just says that energy can change from one form to another, but किस direction में change होगी, that it doesn't explain. For example, we know that a hot object cools down to the temperature of the surrounding. If I keep a hot tea or a hot vessel in a room, it will lose its energy and it will become its temperature will become equal to the surrounding, meaning it will lose its energy. But do you see that the energy from outside comes back to the vessel and it makes it hot again? Or if I burn a paper, it will change to CO2. Does it ever happen that CO2 comes back and makes the paper again? सो दीज आर द थिंग्स दैट वाई डिड दिस नॉट हैपन, ये ऐसा होगा क्यों नहीं है, ऐसा होता क्यों नहीं है. दिस is not explained by the first law of thermodynamics. This was the